Hello YouTube. Today we are going to do add two numbers in Lua and Python. So that is this problem in LeetCode. But first, the requirements are that you need to know what linked lists are. I have a video on it and I'm going to post that on the screen because we are going to use these two classes, which is the node class and our linked list class. You just need the node class though, to be honest. But this linked list is going to help us set up values for our test cases. So without further ado, let's get straight into the video. Hopefully you guys are enjoying these videos, by the way. I think it's actually very helpful for me and doing coding interviews if you guys don't know what LeetCode is. And yeah, this is our first medium problem that we'll have on our channel right now. So yeah, hopefully you guys are prepared for stepping up a notch. It says you are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contains a single digit. Add the two numbers and return the sum as a linked list. You may assume two numbers do not contain any leading zeros except for the number 0 itself. So what does all of this mean, okay? So non-empty linked list, it means that there has to be something in the linked list. So there needs to be like a value in it. And the digits that we are adding are stored in reverse order. So let's go over like some basic examples, right? So this is the example that we were given. 2 plus 5 plus 5 equals 7. Hopefully you guys see that. Like 2 plus 5 equals 7. 6 plus 4 equals 10. But you carry the 1, right? And you put a 0 over here. Oh wait, it's supposed to be 8. 3 plus 1 plus 4. And then this is supposed to be 8. But yeah, that's how you do the answer. Alright, so we have a bunch of examples here. These boxes are like if it shows it's valid or invalid as our input. So would this be a valid input? Well, it would not be. It would be invalid because there is a negative number and we can't have these negative numbers inside our linked list. It says right here that they are non-negative integers. So that's what a non-negative integer, this is what a negative integer looks like, right? So can we have two zeros? The answer is it is actually valid because we can have 0 and 0 as our answer, and that is totally correct answer. You can do 0 plus 0. 0 plus 0 equals 0. So now would this be a valid or invalid input? EC257066. Answer is 76. The answer is, this is actually an invalid input because you guys see this, if we store it like regularly, it's gonna be 0 2 plus 56 equals 67. So this 0 2, we cannot have any leading zeros in the front. And remember, this linked list is stored in reverse order, so we cannot have this in the front. But if the values were reversed like this, right? Then this would be a valid input. But since there has a leading 0, it would be invalid. Alright, so what about this? You see 999 as the first linked list and 1 as the second linked list. Is this a valid input? Well, the answer is it is valid because, there's no leading zeros, and even though it kind of looks crazy, like 999, right? 999 plus 1 is going to equal 1,000, and that is what this answer is, stored in reverse. Okay. Alright, we got a last one right here. 2 plus 56. And that is basically the same thing over here. But guess what? It's a valid input. Why? Because we don't have the 0 over here. So remember these things, why it's like valid and invalid input. So now that we went over like all the inputs that we could have, we actually have a solution for you guys. It deals with carry. So what is this carry, right? Say we're given like 999 and a 1. Okay. If we start carry at 0, so like if we do 9 plus 1 and 10, we would have to put a 0 here and then update our carry to 1. So how is that going to look like? So we're going to have 3 pointers. Why is this pointer like over here instead of like over here? I will give you the reason why. Because when we do 9 plus 1, we're going to have 1 and 0, but we're going to have to store this 0 somewhere, and we have to store it in this answers list. But how do we like make an answers list, right, if we did not have our first node? So we're actually going to store it here, and then at the end when we generate all our values, we're just going to update our answer value to equal to this first value. Hopefully that makes sense for you guys. I'll show you guys another example like later, but yeah. So you guys see how like there's nothing here? That means if L1 equals nil, right? Let's do L2 first. So if L2 equals nil, because we're going to get to a position where it's going to be looking like in our second iteration, our arrows are going to move up over here, and then we're not going to have a value here. So what happens to this thing? Well, what we would do is we would just set it to 0. So let's say if we like iterate through the next step, this 1 right here, we're going to do 9 plus 1. Okay, let's go through the first step actually. 9 plus 1 is going to be equal to 10. So we grab this answers and we put it here now. This answer thingy, answer pointer. But once we move this, we say, okay, now we go over here now. And then we update our carry value to 1 because we're carrying 1 from 10, right? So then we do 9 plus 1 plus what? If we say 9 plus 1 plus nil, this is gonna error. You can't do 9 plus 1 plus nil value because this like it produces an error. Okay, I'm just trusting on that. So every time we like move forward, we're going to be like, okay, since we move forward, we're going to make our L1 equal to here. So what does that even mean? That means, okay, let's say we're starting from here. That means let's try move forward 1. That means we grab this node, we delete it, right? And then this is our new L1. This is going to be our new L1 on our second iteration. Okay. And then on our second iteration, we'll also not have this value of 1 anymore. Okay. But we will update that value to have a value of 0. So on our second iteration, we're on our second one right now. Now we say 9 plus 1 plus 0. So what does that even mean? Well, if we're on our second iteration, this arrow needs to be also here. That means 9 plus 1 plus 0 is going to be 10. So then you say, okay, let's add another 0 because it's going to be 10, right? Then we'll move our pointer, our answer pointer over here. And then what we're going to do is we're going to be like, okay, we've done everything because we've done this second iteration. So just going to drop it over here. Well, this 0 is going to stay here because it's still going to equal to nil or whatever. So it's still going to equal to nil because we say L2 equals 0, which isn't a actual node, it just equals a number 0. I just put that for display and stuff. Well, yeah, and then we get over here, and then we're going to be like, okay, 9 plus 1 plus, since L2 equals nil, right? We're going to say it's going to be equal to 0. So 9 plus 1 plus 0 equals 10. So then we grab this 0 here. We append it to this answer list. And then what we do is we be like, okay, we're done with our third iteration right now. So then we move these arrows forward. This is going to like not be, this is still going to be nil. And then now the green one is going to be nil. But we still have a carry of 1. So what we do is like, we do L1 equals 0, L2 equals 0. So you do 1 plus 0 plus 0. And then we say, okay, now we put our 1 here. And when now, since 1 plus 0 plus 0, our carry is going to be 0 because it's not 10, okay? Our carry is going to equal to, actually, I haven't even showed you guys this, but it's going to be sum equals 10. So our sum, when it equals 10 divided by 10, this is going to be equal to 1. And also 11 divided by 10 is also going to equal to 1. Like, we're going, our highest value is going to be like 18 because 9 plus 9, right? 9 plus 9 is 18. So our highest value is going to be 18. So when we do divided by 10, it's going to be equal to 1. So how do we get this remainder value, right? How do we get this remainder value and actually put it to our answer? That is where we do module 10. So once you do like 10, like 11 module 10, that is going to give us a remainder. It has a remainder of 1. Because it's like saying how many times can 10 fit into this number. Like if you give it like 12 module 10, it's going to say 2. So yeah, that's how the answer is going to be. And our sum is, you know, L1 plus L2 plus our carry. So what we have been doing up here. So that is going to be our whole code, and get rid of this. That means, you know, L1 equals 0 now when it's equal to nil. So yeah, hopefully that makes sense to you guys. Now I'm going to code it in, I think we're going to code it in Python, but this runtime right now is going to be O of n, because n is going to be the number of nodes that we're traversing through. So if we have like 99999, right, then we're going to have to go to each value like in constant time. We're just going to keep going by one by one. And also our space complexity is going to be constant because we're only keeping this pointer, and actually it's not going to be constant because now that I look at it, we have this like space, right? This answer, and that's going to also equal to like this. It just depends on if we're keeping, you know, as our number grows, our answer is also going to grow. So yeah, that would also be n time, n memory. So how would we code that? First, let's code it in Python, okay? So we need our head of the node, which is this 0, right? Because in the end, we're going to return this 1,000 because we did 999 plus 1, and that's going to be equal to 1,000. So we get rid of this extra 0 and we just point our answer over here now. Okay. So this is going to be our answer, or yeah, our answer. I guess we can call it root, and then we can just say list node at 0, list node 0. So we'll give it a value of 0. Then what we need to do is we need to make a while loop that goes through all these list nodes, right? But first we need these 3 pointers, which is the green, blue, and red pointer. Okay. So we need our red pointer, so we're just gonna say answer pointer equals answer root, and then we're going to say our L1 pointer equal L1, L2 pointer equal L2. Now we just say while L1 pointer is not equal to null, so not none, or L2 pointer is not none. And our carry needs to also be not none, or our, oh, we also need a carry here, huh? Carry equals 0. Or our carry does not equal 0. Well, our carry does not equal 0. So if there is like if this is like not nil, so that means there is a value in L1 pointer or whatever. Actually, we don't even need to use a pointer for L1, because if we're updating it, like L1 equals 99 or whatever, we can just keep updating L1's value to the node, the next node. Okay, hopefully that makes sense to you guys. So we can just say L1 and L2. Okay. Now we can say, okay, we need to check if L1, we need to get a value of L. If it equals nil, then we need to set L1 to 0. So that means L1 value equals L1 if L1 else 0. Hopefully this makes sense to you guys. This is like a ternary operator. So if there is a L1 value, or if there is a L1 value, then we would return L1, else we would return 0. So then we'll give it a L2 value, right? L2 value. But yeah, this is gonna be like, you know, if there's a L2 value, then it's the same thing. And then we're gonna say sum equals L1 value plus L2 value plus our carry. And then we're going to be like, okay, carry equals sum divided by 10 equals sum divided by 10. And then our answer dot next is equal to, because our answer root right here and our answer pointer right here, so we need to say answer pointer dot next equals to, so we make our next into a new list node which contains the value of whatever sum module 10 is. Okay, so we would just say list node is going to be equal to sum module 10. Then we would update our L1 value to the next value, like we put it to the next number. So L1 equal L1.next. But if you do L1.next and this is nil, then I think it will error out when you do .next. We're going to say if L1, I'm gonna say if there's a L1, else we're going to say none. Else we can just say none. Hopefully that makes sense to you guys. And then after this while loop is done, then we're done with this. And then we should be good to go. Actually, turn answer root dot next. And hopefully this is correct. It looks fine to me unless I did invalid syntax. Do I have to say is not none? Okay, L2 value, L1 value. Okay. Sorry. This node object has no attribute value, so it's probably val. Just syntax error, guys. Sorry. Time limit exceeded. Oh boy. Oh, I don't think I increase answer pointer, do I? Answer pointer equal answer pointer dot next. Okay. There we go. So I just needed to increase answer pointer, which is this red, and then I needed to change like L2. There was like some syntax errors, but this should be good, guys. This is like the whole code. Let's go. Okay, now we'll do it in Lua. First of all, we're going to grab test cases, which is 2, 3, 4, and 5, 4, 6. So how I do this is, so we have L1 and L2. So then we can just print add two numbers. Hopefully this is going to work. And then L1, L2. Okay, add two numbers. So what we need to do first, right, in here is we need to set our carry to 0. We need to give 3 pointers. Actually, just give the answer pointer and this carry value, because we can just update L1 and L2 inside of this loop. The answer equal, we're gonna give it a node of new, which is 0. Okay, like that's our head over here. That's this thing. So when we say answer root, I guess, and then let's have our answer pointer to like update, which is this red one, to go through the list and stuff like that. So we say answer root dot. Now we need a carry equal 0. If we say L1, then this automatically checks if the value is nil or not. So if L1 is not equal to nil, or L2 not equal to nil, or carry not equal to 0. It's going to be written a bit differently because I don't really know if we can do L1 value equal L1 or 0, because you can't do dot value if L1 doesn't exist. So I don't think there is like such thing. So if we set our L1 value to start at 0, we probably need to set our L2 value as well to equal to 0. So if there is a L1 value, then we say L1 value equal L1 value. And if there is a L2 value, then we say L2 value equal L2 value. And then I think we can update our pointer here, since we already say we gave our values already. So I'm going to just update L1 equal L1 dot next, L2 equal L2 dot next. So that is going to, so we don't need to like do this at our bottom, since, you know, this is like easier or whatever in Python, but in Lua you gotta use these if else. So then we are going to say sum equal L1 value plus L2 value plus the carry. And then we can say our carry equal the sum divided by 10. Answer pointer dot next equal new node dot new, and we can give it a value of sum module 10. And I think in Roblox actually we need to floor this because I don't think it actually gives us 1. I think in Roblox it's gonna give us some decimal value. So math.floor, and then we update our pointer equal answer dot pointer dot next. Okay, and then I think that's about it, except we need to return answer root dot next. Oh my gosh, guys, I need to put root here. I'm so sorry. Oh my gosh. Okay, I thought I'm just dumb, but we had to give the root values. But yeah, it works, guys. It gives 708. We can try it for the other ones as well, if you guys want to see. Attempt to index nil with value. So L2 equals nil. Oh, okay, I see. So if L1 like that, I just need to remember I gotta pass in the roots. Oh yeah, and guys, to fix a root problem, I just updated our linked list to just give in the root, so we don't need to say L1.root anymore, so that, it doesn't happen again. But, I mean, yeah, okay, goodbye, LOL. I'll see you in the next episode. Goodbye.